Thank you very much, Oliver. I'm not sure if we have questions yet. Let's see. Okay, well, we don't have questions for you right now, but maybe we can go back in the meantime for the other speakers. I think we had one comment, so it was not a question, but someone shared that in Germany there is a standard so to standardize the pull test of tapes, which includes a simple artificial aging. Do you want to react on that, Lars?
Yeah, of course, that is interesting. But well, my company is just just a moment. My company is just a civil engineer company, and well, I don't have the mandatory to set in standards like that in Denmark, but I will work at it, of course.
Here yes, about the presentation of Jiri, someone shared that from the Passive House Institute that they have made an assessment of more than 3,000 AIRTightness tests in passive houses, which reached the standards. Well, I don't know if it was on multifamily buildings. Do you want to say a word on this, Jiri? I don't think you say that it was not possible to reach the standard, but yeah, how you.
Yes, my congratulations to this very good achievement, and I hope that we will be able to achieve such results in multifamily residential buildings as well. I think that the results from single-family houses are in line with these results, but we have a lot of work in multifamily buildings and large buildings in general. So hopefully in the future we will be able to present better results.
Okay, we have also a new question for Markus. Someone is asking if that's a technology that is used commercially.
That is, what does this person mean exactly? The one with the, was this a reference to the ultrasonic technology? Because yes, I think it is. I know one of the colleagues. Yeah, yeah, exactly. That's why there's no right now no need without any cool idea how to maybe change it or update it to research any further into that.
Thank you. And someone was interested to have your research. So
yes.
if you can put a link in the chat.
Yeah, either that or I think the slides are going to be sent around afterwards, and there's
yes,
there is a short bibliography that I skipped while my presentation. Then the person can look it up in the slides. Then there's everything together.
Okay, perfect. Thank you. One question for Lars, Jiri, and Oliver. Do you have any statistics or opinion on how OSB3 or OSB4 with taped edges, so without membranes, perform? Is there a proof it performs as good as sealed VCL membranes or not?
Well, if I start with our experience, it has to be USB4 plates. That the other ones is, well, perhaps you can find some. They are airtight, but the 4 one is have documentary for airtightness and are used very well in buildings. And actually, I think if I should build my own house, I will consider using USB. Definitely, it's a very good product, as I see it.
So if I can add my opinion, well, the OSB are not always as airtight as we need, and we had some problems in past with OSB 3 and less problems with OSB 4, but in some cases the buildings or timber structure buildings built with OSB 3 as air barrier layer didn't fulfill the strict requirements for passive houses, for example. All the details were perfect. There were no leakage paths in connections between building elements, and it was necessary in these cases to apply, for example, paint over the OSB in order to achieve N50 0.6. So yes, I don't have any statistics, but I know that some studies exist on this topic. Should be available from AIVC, I guess.
Yeah, I would like to add something. It depends on what you want to achieve.
Yeah.
Do you want to build a passive house, or do you want to refurbish an old building? And I think OSB is a great material to build an airtight layer. Yeah, of course, a little heavy, but you attach it to the beams, you seal the seams, and you are done. And of course, there are quality differences in airtightness and certain OSB types products. I know that the Passive House has done research on that. But for me, discussing OSB as a not airtight product goes in the wrong direction. We shouldn't question that. We should first think, what do I want to achieve? And if I want to have a passive house, I calculate what's the leakage flow over a square meter. And in the DIN 4107, we introduce a method to calculate the leakage over the material, and then you have a reserve for the links that are much more difficult to design and to build. Yeah, of course there are airtighter materials, but perhaps you don't have that high benchmark.
Thank you to the three of you for your answers. We have another question for all of you, which has not been really treated today, but is it reliable to use the measured CO2 decay, assuming a well-mixed space and no significant new CO2 sources, to evaluate the air change per hour? Does someone want to say a word on this?
Perhaps, I don't know. I mean, we have knowledge about airtightness testing since 1980. Correct me if I'm wrong. So we have 50 years of airtightness testing with the blower door, with other types, with fans, with ventilation systems. Perhaps you can do it with a decay of CO2. But why do we introduce another airtightness method when we have one that works fine?
Yes. Yes, I wanted to say what Valerie is writing right now. It's a good method to investigate the actual air change rate at specific boundary conditions at one moment, but here we are interested in air tightness, so we want to eliminate the boundary conditions, and we want to to obtain air changes per hour, okay, but at a specific reference pressure difference, and eliminate exactly the temperature difference and the wind effects. So it's good method, of course, but for another purpose.
Yes, exactly. Thank you.
As Oliver said, well, we have a system to test air leaks today, get the air change range. I have been testing with in that way, but it is difficult. So it's so easy to make a blow-out test today. So why use another way? Why do it another way? Yeah.
And I might add, you don't know where the leaks are. And if you have humidity going through the leaks, then you have mold, or you have wood construction that will be destroyed. So find the leaks, avoid them. It's the main purpose of the test. And of course, venting with leaks could be a solution when you know that the leak is not critical.